Okay, in this problem we're given a 10-inch long wrench, and this wrench is being used to exert a 420 foot-pounds of torque on a bolt in the direction of 120. And you're asked to find the magnitude of F, where F is the force on the end of the wrench that moves the bolt, that turns the bolt. Okay, so what I've drawn down here is a picture of the vector 120, which does not represent F, but it is parallel to F. This is the direction that the force is exerted. That's what this vector represents. And so it's parallel to F, and so it has the same direction or angle, theta. Okay, so keep that in mind. Now, the formula that makes sense to use, since you're basically asked to find the magnitude of F, the formula that makes sense to use, well, you know that the magnitude of the torque vector, which is d cross F, where d represents the handle of the wrench, the vector d represents the displacement by the handle of the wrench, we know that the magnitude of d cross F is the magnitude d times the magnitude of F times the sine of theta. Well, here's the thing. We know the magnitude of the torque vector is 420. We know that the magnitude of the wrench, well, here's the thing. The wrench is 10 inches long, but the torque is given in foot-pounds, so we better change the wrench to feet. So the 10 inches to feet, so that would be 10/12 or 5/6. So the wrench is 5/6 of a foot. We don't know the magnitude of F. That's what we're looking for. But guess what? We can find the next guy. We can find the sine of theta using the picture up here to help us out. So all you need is a little right triangle trigonometry. Drop a perpendicular, create a right triangle from the tip of that vector 120. You know that this side of our triangle is 1. That's the adjacent side. This side, the opposite side of the angle, is 2. And if you use the Pythagorean theorem on this guy, or just find the magnitude of this vector, you'll realize very quickly that you get the square root of 5. So the sine of theta, then, you can just use that triangle to get it. The sine of theta is going to be equal to opposite over hypotenuse, which is 2 over radical 5. And that's exactly what I'll fill in down there. Okay. So if you solve this equation for the magnitude of F, I'll let you do that. I'm going to give you the result. You end up with, I think it's 252 root 5 pounds. And remember, it must be in pounds because we're just finding the magnitude of the force, which is in pounds. You know that because the torque was given in foot-pounds. So that's it.